In the last lesson, we looked at simple interest, but most of the time interest is compounded. That just means it's calculated more than just once a year. So if we had just kept it at once a year, I want you to kind of think about what was happening before when we were doing this simple interest. Our future value was equal to P plus PRT, right? Well, we're not just going to be doing it like that. So this is very similar because the P is factored out, but instead of multiplying the rate by the time, we're going to be going to the nth year. So it's going to happen over and over and over, and we're going to multiply it because it's going to compound on itself. They take your value at the end of the year and tack it on. So it's a little bit of a different way of calculating interest. And I'll kind of show you with this one. This will be an easier way to do it. So if we have $3,000 is invested for 4 years at 9%, how much interest is earned? Well, let's just think about how much we would have. So if we started with the $3,000 and we were doing, 1 plus the rate for that year, so that'd be 0.09. By the end, so this is year 1. By the end of that year, I'd have 3,000 times 1.09 basically. I would have 3270 at the end of that year. So when they go to calculate the next year, they're going to take that 30, now it's 3270. So you're taking what you started with, and now we're taking 3270 times 1 plus 0.09. So I'm multiplying by 1.09 each time, times 1.09. That's year 2. Now for year 3, we're starting with a new balance. So times 1.09. And now we have a new balance. And so forth. Instead of having to do all of this work, this shortcut says we're going to take 1 plus 0.09 and do it to the 4th power, because I'm multiplying by 1.09 4 times. Oops, I forgot my principal. Uh-oh, this should have the 3,000 right there. Oh, darn it. Let's see if I can do this faster. 3,000, 1.09 to the 4th power. And it's going to get us there faster. Now, some accounts, they can compound it annually, semi-annually, quarterly, monthly, or daily. And your stated interest rate is your annual interest rate. So, for these purposes, we're going to continue to call the annual interest rate R, but our interest rate per period is going to be I, because they take that yearly interest rate and divide it up. So let's say you have a credit card and you get a monthly bill. They take your new balance each month and compound that interest. So they would take the annual interest rate divided by 12 to get your interest rate per period. Okay, so let's say if we had $1,000 invested for 5 years at 6% compounded semi-annually, that's twice a year, that's going to actually be 10 times they calculate the interest. 5 years at 2 periods per year. The interest rate for each time is actually going to be 3%, because they take that annual interest rate of 6% and divide it up into the 2 periods per year. So what we can actually do is if we take our principal invested at T number of years at a nominal interest rate of R, and we're compounding M times a year, then the number of periods is going to be M times T. How many times we're compounding a year times the number of years. The interest rate is going to be R divided by M. The interest rate divided by how many times a year we're compounding it. So, most of the time I like to just go ahead and use this formula. So, let's think about this one. For each of the following investments, find the interest rate per period. Okay, so this R over M would be my interest rate per period. So we're doing 12%, so 0.12, and it's compounded monthly, so they're dividing that up during 12 months, so that's going to be 0.01. How many times are we going to be compounding? So that's the N. That's going to be, we're doing it monthly for 7 years. So we're actually going to do 84 whole periods. Okay. Interest rate per period. Well, the interest rate is 7.2, so that'd be 0.072. Quarterly means we're going to divide that by 4. I'm going to have to use a calculator for that. 0.072 divided by 4 gives me 0.018. And the number of compounding periods would be quarterly. Oh, for 11 quarters. Oh, so they didn't give us the number of years. They just told me how many quarters. So be careful there. All right, let's apply it. Jim and Eden want to have $200,000 in Maura's college fund on her 18th birthday. And they want to know the impact on this goal of having $10,000 invested at 9.8%, compounded quarterly, and we want to know the amount on her first birthday. Oh no, they just invested it on her first birthday. So if they invested it on her first birthday, then let's think about how long this would be. So they start with the $10,000. 1 plus the rate is 9.8% divided by the number of times a year it's compounded. And then this would be 4 times, how many years is that? Well, from her first birthday to the 18th birthday, that's actually going to be 17 years. So, 10,000, parentheses 1 plus 0.098 divided by 4, 4, parentheses to the 4 times 17. There's also another way I can find this if I'm using this calculator. So I'm going to go into apps. There's one called Finance. And we're looking at the very first one, TVM Solver. N is going to be this number of periods we've done. So this would be 4 times 17. The interest rate, 9.8. And notice it has the percent, so we're writing in the percent. The present value, or my principal value, is going to be, and we actually put it in don't ask me why, but as a negative. I've never understood that, but we're going with it. Okay, do we make any payments, additional payments? No. We're going to end up trying to find the future value, so I'm going to leave that blank here. It'll fill it in for me. And the number of periods and the number of compoundings is 4. And we want the ending value, so I'm going to leave it with end there. We're trying to solve for the future value, so I've got my cursor on the future value. If you'll notice at the bottom of your screen, it has green solve above enter. And my green button is alpha, so I'm going to press alpha solve. And it found my future value. How much compounded interest did the investment earn? Well, if we have this much and we started with 10,000, then we would just take our future value minus the original investment, and we have earned $41,857.73. So, what impact would that have on the goal? Well, they wanted to have $200,000. So we're 25% of the goal has been reached. So 25% of the goal has been reached. Okay. Present value. What amount must be invested now to have $12,000 after 3 years if the money is worth 6% compounded semi-annually? So I'm going to do this 2 ways. Let's start with, so I'm going to use the formula S equals P parentheses 1 plus R divided by M, MT. The future amount is $12,000. We don't know what our principal is, but we know the rate is 6%. Compounded semi-annually is twice a year, and that'd be 2 times a year for 3 years, so that'd be a 6 up here. And we would just solve the equation. So I'd end up with 1.03. So 12,000. This would be 1.03 to the 6th power. Gives me 1.194 times P. But notice I rounded there. It's not going to be as accurate as if I go up in the calculator and select the whole number. And so my principal should be $10,049.81. Let's compare that to doing it in the app. Okay, so the number of periods is 6. This was 6%. This is what we don't know this time. No payments. We want 12,000, and we're compounding twice a year. I'm wanting the present value, so I put my cursor on the present value, and I hit alpha, enter, and it gives me $10,049.81. Let me see how much more we got of it. Okay, let's do this last one in this section, and then I'll put the rest in another video. Rate earned. 3 years after Google stock was first sold publicly, its share price had risen 500%. Google's 500% increase means that $10,000 invested in Google stock at its initial public offering, which is what IPO stands for, was worth $60,000 3 years later. What interest rate, compounded annually, does this represent? So annually means it's that helps us out a lot. So this M is a 1. So 60,000 was $10,000 invested at 1 plus, we don't know the rate, divided by 1. And this would be 3 years at once a year, so just a 3. And this would take a little bit of solving, right? If you were going to do it by hand. Now I want to show you how you can do it in a calculator. We're looking for the interest rate this time. We started with $10,000, and it was our investment, so that's why it's a negative, really. And we're getting $60,000. And how many times was it being compounded? Once a year. And we want the interest rate, so alpha solve. And it gives me that this earned 81.7% interest. That's amazing. So I just wanted to briefly show this. If we invest a sum of money, say $100, the higher the interest rate, the greater the future value. So notice this is investing $100 at 5% interest, at 8% interest, at 10% interest. So in the first few years it doesn't make much of a difference. But as the years progress, there's definitely this spread out. So the higher the interest rate, the more money you're going to make off of it. This is a rather long section. Let's pause there.